Hi, we are in group number 7. Our team is composed by Francisco Emiliano, Diego Cruz, and Paulina Zamora. We are students of Prepa de Guadalajara, and our teacher is Roberto Cano Guzman. And we are going to show you a problem of simple harmonic motion.
Okay, so simple harmonic motion. What is it? It's a motion where a restoring force is applied that is proportional to the displacement and the opposite direction of the displacement. So it will be like going to back and forth all the time. Period and frequency of the wave. Period is the measure of the time it takes for the wave move the cycle completely. We usually measure the wave period in seconds and presents it with the letter T. Here's our formula. T equals to 1 divided by frequency. The frequency is the number of waves that pass a fixed point in our given amount of time. That it will be like the same formula. Instead of having T, in this place we have F and we change it F with T. The amplitude is some of the most important things to making the wave. Is a measure of the displacement of the wave from its rest position. It will be continuing all the time until you can stop it or you decide when to cut it down.
Talking about examples of simple harmonic motion, we can name objects such as guitar strings, classic pendulum, or actions like bouncing a ball. The previous can be an example due to the problem with mechanical or real-life situations, because there's always some sort of friction causing a loss of energy. One of the inventors forgotten by history is Edwin Armstrong. He is credited with the invention of FM radio. Until that moment, in 1933, the commercial radio had been of amplitude modulate, what popularly is known like radio AM. The genius of Armstrong was based on not thinking about modifying the amplitude of a radio wave to create the sound, but to vary the frequency of the carrier wave.
Okay, so we are going to apply what my partner showed you, and this is by making a problem about the topic that we are watching. So we read it, and the carrier wave of an FM radio signal is modeled by the function y is equal to a sin times 2b times 9.5 times 10 to the 7 potens times t, where t is measured in seconds. So what we're going to do first is to find its frequency, and we have here, first of all, we divide all the equation over 2 pi, and then we give it the value of w. So by dividing these two numbers, we obtain this quantity, and that's the frequency. And we can do this operation in the calculator, and the result will be 91.5. So we can erase this one. Now we are going to show you how to find the period of a wave. As we saw in the previous part of the video, the frequency and the period are reciprocals. So we can say that the formula of the frequency is equal to 1 over the period. And so the period is equal to 1 over the frequency. So the only thing we have to do is divide the quantity that we obtained recently over 1, and our result will be this one. So as the last step on this problem, we have to graph this function, this whole function and its results. And first of all, we identify what we're going to put in each part of the graph. So first of all, we have the period, that is a kind of that takes care of the the limit of the of this wave. So we have in the positive side this 1.05 times 10 to the minus 8 potens, and in the negative side the same but in a negative sign. And about the frequency, what my team and I did was to first put the frequency as a constant and like adding 91.5 in each step. So we have like 193, 274.5, 366, and so on and so on. So we like achieve making the frequency of our graph. And the only thing we have to do is to like making the movement, the classic movement of a sine function that is like this one, beginning from the zero. And as you can see, also we add the p sign on 180 and 360, just to show you the position of pi in this graph. Well, as a conclusion, we can say that this project was very interesting because the topic that we develop, it's very important for real life, not only for the school and the grade and the semester, but for real life. Okay, I think it's very important also that in this trigonometric subject we are also watching things of physical, and it's important because the next semester we're gonna have physics, and I think it's important to start like understanding the subject and to not be so impressed at the time to see like physics formulas and concepts, so we can understand it better. And that's all. What do you think? Also, talking about the research that we did on the making of this project, what I learned was to appreciate and comprehend the legacy of Edwin Armstrong, that was the creator of FM radio, because by that time, like by 1933, there was not much knowledge about radio waves and things like that. It was only modulated amplitude that was radio AM, and I think that is very important to transcend and to find out new things.
Okay, so my conclusion from this project is about learning how to the waves can we understand it, and how our teacher Roberto Cano is helping us to get induced on the physics problem, so we can understand better in this next semester the problems or the physics that we are going to get used to, and we can see it not like a grade or only just for our class. We can see it like on our lives of how we can use it to like in different type of problems, like the water, it could be the sea, the waves that it produces, its physics, the how we can play or do such things that we usually do. We can relationate it with physics problems, and they can help us to be more helpful in our future lives, and we can help another person that doesn't understand like quite how physics goes, or how it or how the problems are solved.